Hey guys, welcome to lesson 6.1 notes, and we're going to talk about vertex form of a parabola. So the equation is going to be y is equal to a times x minus h squared plus k. And a determines whether the parabola opens up or opens down. H and K are going to be where the vertex come from, but notice this minus, so it's going to always feel opposite of what it should be. So like for instance, this one right here, our vertex is going to be positive 4, positive 6. Same thing with this one. Our vertex is going to be positive 2, negative 3. We are also going to talk about this thing called the axis of symmetry. And when you have a parabola, the axis of symmetry is going to cut that parabola in half. And it's always a line. So think about like x equals whatever. That's a vertical line. And so it's actually going to be a line when we talk about that. Okay, so let's go ahead and get started. One of the first things that I notice is that this is opening down. So it looks like this. And this is called a maximum. If it opens up this way, this is called a minimum. Okay, so this has a maximum value, and let's go ahead and get caught up. So this is 4, 6, and our axis of symmetry is always going to cut it in half, and notice that it goes right through that vertex. So whatever our x value for our vertex is, that's what the line is going to be for axis of symmetry. So axis of symmetry is x is equal to 4. So I'm going to start there, 1, 2, 3, 4, and I'm going to put a dotted line there. And I know that everything's going to work around that. So 1, 2, 3, 4, 5, 6, and I know it's going to go down. Okay, I think I'm going to come back to this in just a second. Let me kind of talk about how to set up this chart. This chart's kind of a big deal. It's going to guide us through how to graph. So we're going to put the vertex in the center, always, always, always put the vertex in the center, and kind of think about this as a sideways number line. So if we had a number line, this would be like 5, and this would be 6, and this would be 3, and this would be 2. So we're just literally just making a number line around that x value. Something else, if we set it up like this, these y values will always be equal to each other, and these y values will always be equal to each other. So what I like to do is I like to start with something like, I'll plug in this one right here. I usually plug in like these numbers down here. They're a little bit easier. Okay, so if we plugged in, let's come back up here. If we plugged in a 5 right here, let's see, 5 minus 4 is 1. 1 squared is 1. And then we have negative 1 plus 6, which is 5. So I know that not only a 5 goes here, but a 5 also goes here. Okay, let's do another one. Let's do 6 this time. Okay, so 6 minus 4 is 2. 2 squared is 4, and then we have negative 4 plus 6, and that's going to be 2. Okay, and this helps me to graph it. So I'm just going to take each one of these and graph them. So let's see, I have 5, 5, and also 3, 5. And then I have 6, 2, and 2, 2. So it's going to look something like this. Right, that kind of looks off a little bit, but you guys get the idea. Okay, let's talk about the domain. So as these values are going down, you see how they're slightly going off to the right? And this is slightly going off to the left every time. So it's going to eventually go forever to the left and forever to the right. And since domain deals with our x values, there's nothing, like there's no x that it can't be. So as we approach infinity, our x values will all be used up. So that's where that set of all reals comes in. Our range is always going to be correlated with this number right here of our vertex. So look at this. This is where our range happens. So everything starts happening right here at 6 and below. So I'm going to say y is less than or equal to 6. Okay. Sometimes I can see where it crosses the y-axis, but like we can't see. So I have a feeling it's like way down here. We can't tell. So if you don't know where it crosses the x-axis, what you're going to do, our y-intercept is always 0 something. So what I'm going to do is I'm going to plug in 0 for x, and then just figure out what my y value is. So let's see. So this is going to be 0 minus 4 is -4. -4 squared is 16. That's going to be a -16. -16 plus 6 is going to be -10. So again, always to find the y-intercept, you're going to set x equal to 0. Okay, I think we've answered all the questions. We've done our graph. Let's go ahead and do another one. So our vertex here is going to be +2, -3, and I'm going to put that down here, +2, -3. And then I'm going to work around my x values. So let's see, this is 3, 4, this is 1, this is 0. And this is nice because I can tell, I can tell that I already have my, my y-intercept there. Okay, so let's go ahead. I know these y values are going to be the same, and let's go ahead and start plugging in. So I'm going to start right there. I'm going to plug in 3. So 3 minus 2 is 1. 1 squared is 1. 1 minus 3 is -2. So this is going to be a -2, and that's going to be a -2. So let's do 4 now. So 4 minus 2 is 2. 2 squared is 4. 4 minus 3 is 1. So, oh, and we can also do the axis of symmetry. So the axis of symmetry is always going to match this guy. So I'm going to start here and do my axis of symmetry. And then I'm going to start plotting the points. So let's see, 2, -3. And then I have these 2 points here. And I have this point here and this point here. Okay, I think we got it. So my parabola looks something like that. So the domain is always going to be the set of all reals. We lucked out right there. We already know our x or y-intercept where it crosses the y-axis, which is 0, 1. And our range is going to be y is greater than or equal. Let's see, how low does it go? Right there, -3. And again, we can tell by the y part of our vertex. Okay, let's do 2 more. See if you guys can do these 2 on your own, and we'll come back and talk about it. Okay, here are the other 2 graphs. This one's kind of weird because you have a fraction here. Don't let that freak you out. Still, the y-intercept, we were able to see it right here. That was kind of nice. And I think that's all I want to say about that one. Number 4, these are kind of tricky because they're kind of hard to see the vertex. So notice, like, if I were to rewrite this, like x minus 0 squared, that's the same thing as this. And so you can kind of see the vertex a little bit easier like that. When it's ever like an x squared minus something, your vertex is always going to be 0 and then whatever that something is. So that is it, guys.